sorry ass DJ.
Hi guys, I'm Janmeco Didinampo from Blessed Math 2A of Kapalong College of Agriculture, Sciences and Technology. And for today's video, we will learn how to solve linear programming problems using graphical method. But first, we will discuss what is linear programming. Okay, let's go! Linear programming. Linear programming is a process of optimizing the problems which are subjected under certain constraints. It means that it is a process of maximizing or minimizing the linear functions under linear inequality constraints. The problem of solving linear programs is considered as the easiest one. Next is graphical method. Graphical method is used to solve problems by finding the highest or lowest point of intersection between the objective function line and the feasible region on a graph. We can use graphical method to solve linear optimization problems involving two variables. Next is steps for graphical methods. Step number 1 is formulate the LPP or linear programming problems. Step 2 is construct a graph and plot the constraints line. Step 3 is determine the valid side of each constraints line. Step 4. Identify the feasible solution region. Step 5. Find the optimum points. And then step 6 is calculate the coordinates of optimum points. Step 7. Evaluate the objective function at optimum points to get the required maximum or minimum value of objective function. Okay, now let's apply these steps. And now let's have an example. Maximize z is equal to 4x plus 6y subject to the constraints 20x plus 10y is less than or equal to 200. And our second constraint is 10x plus 15y less than or equal to 150, where x and y is greater than or equal to 0. But before we continue, let's rewrite the inequalities to equalities. 20x plus 10y is equal to 200. Then 10x plus 15y is equal to 150. And now, in order for us to get the coordinates, we need to solve for x by setting y equals to 0. So 20x plus 10y is equal to 200. Then 20x plus 10, then y is equal to 0 is equal to 200. Then cancel out 20x is equal to 200. Divide both sides by 20. Cancel. X is equal to 10. And we have the coordinates 10 and 0. And next, we'll now get the y by setting x equal to 0. So 20x is equal to 0 plus 10y is equal to 200. Then cancel 10y is equal to 200. Divide both sides by 10. Cancel. So y is equal to 20. And now we have the coordinates 0 and 20. Let's solve the second constraint. Same process. Let's solve for x by setting y equal to 0. Then 10x plus 15y is equal to 150. Then 10x plus 15 and y is equal to 0 equals 150. Then cancel. 10x is equal to 150. Then divide both sides by 10. Then cancel. X is equal to 15. Then we have the coordinates 15 and 0. Same process. We'll get the y by setting x to 0. X is equal to 0. Then 0. Then 15y is equal to 150. Then cancel. 15y is equal to 150. Divide both sides by 15. 15. Cancel. Y is equal to 10. And now we have the coordinates 0 and 10. And now we need to plot the constraint line where x is equal to 10 and y is equal to 20. And then x is equal to 15 and y is equal to 10. And now this is our feasible region that satisfy all the constraints of the problem. Feasible region. And then we need to plot the corner points. So A 0 0 and our B is 10 0 and this is our C and this is our D 0 10. And now we'll need to solve the C. And now we need to solve our C, which is the intersection point. So equation 1 is equal to 20x plus 10y is equal to 200. So 20 using the addition property of equality. So 20x is equal to 200 minus 10y. So divide both sides by 20. So x is equal to 10 minus 10 over 20y. So let's simplify the negative 20 over negative 10 over 20. So x is equal to 10 minus 1 half y. So this is our x. Then equation 2, 10x plus 15y equals 150. So 10, then substitute our x is 10 minus 1 half y plus 15y equals 150. So 10 times 10 equals 100. Then 10 times 1 is equal to 10, divide 2 is equal to 5y plus 15y equals 150. Then negative 5y plus 15y equals 150 minus 100. So negative 5y plus 15y equals 10y equals 150 minus 100 is equal to 50. So divide both sides by 10. So y is equal to 5. And then substitute the value of y by 5. So x is equal to 10 minus 1 half, then 5. So then minus 5 times 1 is 5. So 5 over 2. So x is equal to 7.5. So the value of our c is 7.5 and 5. And now we need to find the value of the objective function z is equal to 4x plus 5. So we have the coordinates 0, 0, 10, 0, 7.5 and 5, and 0 and 10. Then the value of objective function is 4 times 0 plus 5 times 0 is equal to 0. 4 times 10 plus 5 times 0 is equal to 40. So cancel 5 times 0. 4 times 7.5 plus 5 times 5 is equal to 55. 4 times 0 plus 5 times 10, so cancel, equals 50. And our maximum value of z is 55. Therefore, the maximum value of z is 55 at the point C, which is 7.5 and 5, where x is equal to 7.5 and y is equal to 5. And the maximum value of z is 55. And that's all for today. Hope you learned something. Don't forget to like and subscribe.